All right, we're gonna do a video based on just the third page here, just the third page. And the first problem on the other page. I want to show you this note. All right, so we should be able to expand binomials now that aren't just a plus b. All right, we'll have terms that represent a like x and terms that represent b like -2. And in order to do that, when they introduce this with something a lot of people find confusing, they've got this binomial theorem written in mathese, right? We got a math language that we're using. That means if I take any value of a plus b, and again, they don't have to be a plus b, what happens is we get a coefficient. That's what that c is, right? That'll be the coefficient in front, based on, hey, you know what? The whole number, that is the row that we're in, plus the position on the row, and then a to that power and b to the 0. And then if you look at it, just like when we were talking about the other one, the first term, always the power goes down by 1 every single time, and the second term, the power goes up by 1. So 1, 2, 3, all the way until, hey, b is equal to n. So I'm going to write this first one, and I'm just going to explain it so we can use it. Like this guy right here. Obviously, this would be my third row. And let's just make sure that you understand the third row on here is really, if I count down, that's the 0 row. So the third row is here. So when I do this, I should get 1, 3, 3, 1. Well, let's keep that in mind as I'm going to show you how to use a calculator. But my answer should be 1, 3, 3, 1 when I'm doing coefficients. And we'll show you why we do that on the next note page. Because sometimes you don't have to expand the whole thing. You can just get a specific term. But for right now, we're going to expand this, and there's always going to be one more position than there is exponents, because we've got that 0th power, that 0 position in the row. And so if you look, we got 1, 2, 3, 4 when there's 30. This one's going to have how many? It's going to be like 8 sections here, right? And this one's going to have 5 sections. This one's going to have one more than 5, right? It's going to have 6 sections. So there'll be always one more place in this sequence right here than there is a power. So let's get to how we got. I see this as c to the 3, 0, right? That's the power I'm going to in the position, right? This is 3, 1. This is 3, 2. And I'm going to stop at 3, 3, right, as I progress, right? Third row, 0 position, first position, second position, third position. I'm going to show you once again on here, right? Third row, 0 position, first, second, third position. So just like the first row is the 0th row, the first position on here represents the 0th position. All right. Now, this x gets cubed because that's the highest power available for it. And if you'll notice, they should always have a sum of 3. These exponents, the -2 isn't there on this one. Now that's x squared. That dropped by 1 and -2. The second term is to the first power. X drops by 1 to the first power, -2 goes up to the second power. X disappears or to the 0 power if you want to write that, and we got -2 to the third. So as we go through, I'm going to show you how to use a calculator, and then we're kind of going to ditch this calculator for a little bit. We're going to come back to it on the last page, because this really takes much longer than it should, and so we're going to practice enough that we don't have to do it on the next 4 problems. So if I wanted to find 3, 0 right here, I would do this. I would plug in my 3. I'm going to hit the math button. This is very important. I'm going to go over to probability, and I'm going to do combinations, and then I'm going to say 0, and that's going to be a 1. So let's get all of them while we're in here. I'm going to say 3. I'm going to go to the math button, combinations. I'm going to say the first position, and we're expecting a 3, right? Well, there it is. I'm going to say 3. That's the row I'm in, right? Then we're going to go to the math button. I'm going to go to probability, combinations, and I'm going to say the second position. We're expecting another 3, yeah? And I'm going to say 3, and then we're going to hit the math button. Let's hope this all fits here, probably. Not that we don't have it memorized now. Combinations, say the third position. So we sure enough, we got 1, 3, 3, 1. So let's do that. Let's replace that. This number is just 1, and that's an x cubed, so I could say 1 times x cubed, plus this number is a 3, times x squared times -2 to the first power, right? This number we did on the calculator, that's also a 3, right? Combination, third row, second position is 3, and that's x to the first, and that's -2 squared. I should put my plus sign in there, and I didn't. And this number's a 1, and we've got negative 2 cubed. So if I figure this out, right, that's just going to be x cubed plus negative 2 times 3. So let's change that plus to a minus. Right? I should have taken care of my sign first. Negative 6x squared. That's going to be a positive 4, right? Because negative 2 squared is positive 4. So it's going to be a plus 12x. And finally, that looks like negative 8. And we're going to go ahead and highlight that. I'm going to show you a much easier way to figure this out really quick. And I think you'll like this way a little better, right? What if we use, and I'm even going to fold this so I can see it. Really, this is probably a much quicker way if you have to expand the whole thing. What if we used, we don't have the 7th row there. So it wants us to get the 7th row. Well, you know what? It probably wouldn't be too hard to go ahead and get that 7th row, would it? So let's go ahead and do it. Let's go one further down and get that 7th row. I'm going to say 1 plus 6 is 7. But those guys add up to what? 21, and then 35, and then this and this are 35, and this are back to 21. That are 7 and 1. We're going to call this row 7. So let's fold that a little differently. I'm going to show you how nice and easy this is to do. All right, so I'm going to work, and here's where we go. My first position's a 1, and that x gets all those exponents, all that power. My next position is a 7, and that is x to the 6th. That goes down by 1, and now y to the 1st. My next position is, think about it, right, 21. And my x is now gone to a 5th power, and my y has gone to the 2nd. My next two positions are 35, and each time my x drops by 1 and my y goes up by 1. So my x drops by 1 and my y goes up by 1. I think I left myself enough space. Kind of hard to see the end of the page here because I have other pages underneath it, and I'm old. So I go back to 21, and my x is now, oh, did I mess that one up? I did. I should have made this to the 3rd power, huh? And this one should have been to the 4th power. I made a mistake. Those switch places. And still, look, all the sums, 6 and 1 are 7, 5 and 2 are 7, 4 and 3 are 7, 3 and 4 are 7. It's going to be 2 and 5, still 7. We're almost to the end, right? I'm not seeing in my paper, which is good. And that x is now going to be the 1st part. You don't have to write it. And the y to the 6th. And finally, I don't need that 1, right? Because that 1 is my last term. I'm just going to say y to the 7th. All right. So here we go. I'm going to do 2 more with you, and I'm just going to show you how kind of easy this is, right? So this says 4th power. Well, this is my 4th power row. That's row 4, right? So there should be 5 turns. Let's count and make sure we're okay. 1, 2, 3, 4, 5. That's a good way to check. It's always one more than this, right? So I'm going to say 1, and then my x gets all those powers. And then I'm going to say 4, and my x gets 3 of them, and my, watch this sign, -1 gets, negative y gets a power. I'm going to get my next constant, my coefficient, my 6, my x is squared, and my y, my negative y is also squared. I almost wanted to drop it because the sign goes away. My mind got ahead of me. My 4, my x is now to the 1st power. Should have written it like that. I don't really need that 1st power, do I? But my negative y is now to the 3rd power. And I don't need to write a 1, and now my negative y has all of those powers. Notice, again, that's the sum of all of them. Look, 4, 4, 4, 4, 4, all the way across. 1 and 3, 2 and 2, 3 and 1. And let's go ahead and simplify. Well, this is just x to the 4th, right? This is, well, that negative stays there because it's to the 1st power. So I'm going to bring it out front. And again, I should have figured that out before I wrote that sign. -1 and 4, -4, right? And I have x cubed y to the 1st power. That negative is squared, so it's positive, so I can keep my plus 6, x squared and y squared, right? It's no longer negative. Oh, minus, right? Because negative y cubed is still negative, so I'm going to say minus 4x y cubed. And the 4th power, any even power is going to make a negative inside go away, so this is plus y to the 4th. So I'm going to do one more, and if you'll notice, there's one on the next page right there. You see it. I'm going to leave that one to you to try. All right, compare with your partners in class, and let's do D. How long is this right now? It's getting pretty long, but we can go through this one pretty quick. So here we go to the 5th row. All right, so here's my 5th row, and watch how easy. So I'm going to put a 1 there, and then my 2x gets all of the power. All 5 of them go to the first term. And I'm going to put a 5, and now that's 2x to the 4th. Right? And then, what is that, 1? Well, I'm just going to keep increasing the power on 1, which doesn't change a thing, does it? And then I'm going to put a 10. And now my 2x is now to the 3rd, and my first power, my number 1 is to the 2nd. And then I'm going to put another 10. I'm just working across as I go, plus 10. That gives me 2x squared, and now that's 1 to the 3rd power. Well, that's kind of a fun number to have there. It makes it easier. Plus 5, and I get 2x now to the 1st power, and now that's 1 to the 4th. And then I get 1 to the 5th power, right? Now that 1 over here gets all 5 of those powers along, just like the 2x got all 5 at the beginning. So we go through, we shouldn't be able to figure it out. Let's see, 2 to the 5th power. I'm just going to count as I tick mark. 2, 4, 8, 16, 32 times 1 is 32x to the 5th. Plus, well, that's 2 to the 4th power, right? So that's 16 times 5. 2 to the 4th power, 16 times 5 is, what do we got, 80? That's x to the 4th, and 1 kind of just stays the same. We don't actually have to write that 1 at all, do we? So 2 to the 3rd is 8 times 10, which is also 80. I feel like I messed up there, but I don't think so. Is it 80 twice? Well, probably. It feels weird, but my mind says it's correct. 2 squared is 4 times 10 is 40, x squared. And 2 to the 1st power is just 2, right? Times 5 is 10. I've got x. And again, that 1 is just kind of dropping off each time. And 1 to the 5th power is my last term, which is 1. So there it is. So I'm going to pause here. I am going to turn it over, or show you the next page anyway. So I'm going to show you the next page, page 3, and or page 4. And I want you to try this guy. And I'm going to pause here. And depending, I may not even make you do this without worrying about the answers. I may have you do this in class, but just follow what I told you yesterday in class on what to do. I'm going to kind of measure the distance and length of these videos, and we got a long class tomorrow to kind of practice some stuff too. So I'll talk to you soon.